All right, hello everyone, welcome back. In this video, part 3 of the logic series of video lectures, we're going to talk about the specific logical fallacies that I see most often in writing and the ones that I really want you to be aware of. So make sure that you can make sense of these, that you can identify them, because your ability to identify them is what's going to help you out later on this week. So, question. Is evidence alone enough to convince an audience? Now, we've talked about inductive and deductive reasoning and conditional statements and things like that. So what I want to dive into are kind of the specific logical fallacies, and there are 5 of them that I want to go over. Now, there are a ton of logical fallacies, and if you take a philosophy class, there seems to be a logical fallacy for everything, and it's very hard to keep track of all of them, and that would be at least a full quarter's worth of study. So we're just going to focus on these 5. So we're going to focus on straw man, hasty generalization, red herring, slippery slope, and circular logic. So those 5 are the ones that I want you to be aware of. And I want you to be aware of them not just in your own writing, but I want you to be able to kind of identify them in other people's work. So the first one here, right, and this cartoon says, you really shouldn't make straw man arguments. Oh, well, then I guess we should just not have arguments at all. Okay, so this is a very good example of a straw man argument, right? Clearly, whoever made this cartoon knew what they were talking about, because this is what happens when, person B in the green shirt here is just mischaracterizing or exaggerating the first person's argument. And you'll see this in politics, you'll see it in the news, you'll see it on social media. Maybe in an argument with a friend or a partner where the other person is just changing what you said. It's kind of like they're putting words in your mouth. So the definition that we're going to go with is from a site called logicallyfallacious.com. And their definition is, straw man substitutes a person's actual position or argument with a distorted, exaggerated, or misrepresented version of the position of the argument. Now, this may be done intentionally or unintentionally, but in either case, it is a fallacy that we want to keep an eye on. Now, if we see somebody, we're having a discussion with somebody, and they seem to be committing this straw man, mischaracterizing what we're saying, we can simply say, well, that is not what I said. What I said was X, Y, or Z, and you seem to be misunderstanding, or maybe I wasn't clear, or whatnot, however diplomatic you want to be with that. So that is the first one, which is straw man. The next one, and hopefully you can see this, it's tricky to catch sometimes. It sounds easy in thought, at least to my mind. So they say, what is the key to success? It is to hire the right employees. And how do you know you hired the right ones? You know because the business is successful. So this key to success is circular reasoning. Yes, because circular reasoning is the key. Okay, so circular reasoning is where you're basically using the conclusion in the premises. So if we think back to that if-then statement, right? So if we said that person is popular. Why are they popular? Because they have lots of friends. That is essentially circular reasoning. So circular reasoning, again, from logicallyfallacious.com, is, quote, any form of argument where the conclusion is assumed in one of the premises. And if you look out in the world, you will see this quite often. All right, the next one hopefully is relatively easy. So our little penguin friend here says, penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. Right. So again, at the bottom it says penguins are clearly not very good at logic. I have no idea. I don't want to, prejudge penguins. I bet they can be pretty smart, right? So this hopefully sounds a little bit like we're jumping to conclusions here. And this is what we call hasty generalization. So hasty generalization is drawing a conclusion based on a small sample size rather than looking at statistics that are much more in line with a typical or average situation. So if you think about the examples that we used in deductive and inductive reasoning, we want the most thorough sample set we can acquire given our time and resources. So again, we don't want to jump to a conclusion based on one example or two examples. We want to see however many examples we possibly can to make sure that we are as right as we can be, or as Feynman would say, we know that we're not necessarily right, but we know when we are wrong. Okay, the next one. And this is where things get a little bit tricky, and we'll go over this and then I'll explain why I think this is tricky. So the kid says, "Dad, can you get my ball out of the gutter again?" And the dad says, "This is the third time this afternoon. I thought I told you to play out back." And the kid says, "Relax, Dad. It's just a ball in the gutter. It's not as if I've been embezzling money or killing people, right? Aren't you glad I'm not stealing or murdering?" And then the kid says, "I always have to help Dad establish the proper context." Okay, so if you're thinking this looks a little bit like straw man, you would be kind of correct. And I think that that is where things get a little bit tricky. This is a fallacy called red herring. And this is an attempt to redirect the argument to another issue to which the person doing the redirecting can better respond. The red herring is a deliberate diversion of attention with the intention of trying to abandon the original argument. So again, what's happening in red herring is this sort of deliberate intent to, we start out talking about X, but now I'm changing the topic, right? It's not a non sequitur. A non sequitur is, changing to a completely random other topic. But again, as the kid said, he's changing the context. So instead of focusing on the ball in the gutter, the dad is now like, "Oh, well, yes, you're not, in jail," or something like that. So again, try and, if you need to, you can ask me, I can give you more resources, or you can do some digging online on your own, do some research, practice those skills to see the difference between a straw man and a red herring, because it can be pretty tricky. And this is where students often find things a little bit blurry. Okay, should be the last one. Okay, so the last one here, and one of my all-time favorite logical fallacies. So the guy in the tan jacket says, "Your recycling could be a serious threat to our beloved seagulls' nesting grounds, the town dump. And think about this. No seagulls equals fewer car washes equals fewer jobs equal more crime. Your recycling program will condemn our fair town to chaos. Citizens will flee in panic, roads will fall into disrepair, fires will rage remorselessly." And the guy in blue says, "The good news is, if there are zombies, we'll be safe." Okay, so hopefully you're thinking, wait a minute, in 4 panels of this cartoon, we've gone from recycling to basically the apocalypse. And this is what we call slippery slope. And when we say that something is a slippery slope, it really means that some really minor or somewhat insignificant first event is suggested to lead to a more significant event, which leads to another one, and so on and so forth, usually connected by the next thing you know. Maybe you've seen people do this, and they'll take some relatively minor incident and turn it and spin it so that leads to something worse, that leads to something worse, that leads to something worse. Okay, so if we were to go back to this one with a kid and the ball, this one is not that sort of slippery slope, because that would require the dad to say, if you keep doing this, then the next thing you know, you're going to be breaking windows, and then you're going to be, doing graffiti, then you're going to blah, 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 and then it would end up with stealing and so on. So that's why there's a little bit of a difference there. Okay, so the last thing that I want to talk about here briefly is the idea of causation and correlation. So this is a little quick aside, because I think this is one of the other places that people often are misled or intend to mislead others. So we'll look at a graph here in a second, but when we think about correlation and causation, you can kind of think about it this way. Let's say that every time you have cereal before class, you do well on a test. And so you think, okay, then if we were to think that the reason we did well on the test is because we had cereal for breakfast, it's a correlation. We don't know if that is the cause. Maybe we have cereal all the time. Maybe, it's just chance. There does seem to be a correlation between the two. One happens and the other one happens, but we can't say definitively that one happens because of the other. So the graph that we're going to look at here, so this is a great sort of humorous look at causation and correlation. This is from fastcompany.com. So it shows the 92% correlation between the consumption of sour cream and motorcycle riders killed in non-collision transport accidents. So it's a little bit silly, but the point is that people will try and connect two things that are not necessarily directly related, right? They are correlated. They have a similar trend, but we probably wouldn't say that the consumption of sour cream is leading to or is the cause of these accidents, nor would we be likely to say that the accidents are the cause of the sour cream consumption. So what we want to remember is if we're looking at correlated data, we want to make sure that we can claim that one causes the other. So kind of keep an eye out for this trap. I do find that this comes up a lot in, say, like news articles or debates or things like that, where people show that there is, there are two things that are correlated and therefore one must cause the other. And it's very much the same as the earlier conditional statement of if it is raining outside, then we don't go outside to play, so on and so forth. That would be a cause and effect. The cause is if it's raining, and the effect is we don't go outside and play. In this case, right, causation and correlation, one thing should cause the other, and we should be able to argue that. So make sure that you kind of have an eye out for this. I don't want to get too much into the weeds because it is something that happens a little bit more in statistics, but just see if you can find these out there in the world as you're kind of looking around and doing your own personal explorations. All right, so there you go. If you have any questions, comments, concerns, jokes, memes, or recipes, please let me know. Otherwise, I'll talk to you all in the future.